Okay. The new topic in the unit number 3 is the notch sensitivity. We are going to understand this notch sensitivity in terms of stress concentration only. It is a part of stress concentration. You can understand it by the name only, that notches means what, the corner point which it develop with the help of cracks, and its sensitivity, how it create a stress concentration on product. Let's see. It is defined as that notch sensitivity is defined as the susceptibility of a material to succumb to the damaging effect stress raising notches in fatigue loading. The notch sensitive factor Q is defined as follows. Okay, actually, what happens when fatigue stress concentration factor can be expressed in terms of notch sensitivity? We have seen the fatigue stress concentration factor. Okay, and based on this only we can explain the notch sensitivity. So it's a dimensionless factor and it introduced to add effect of notches on stress concentration. Okay, so means the factor is what, this is a dimensionless factor and it is introduced to add a effect of notches on stress concentration. Means due to cracks, what types of stress concentration effect on stress concentration. So this factor is the notch sensitivity factor which we are showing here. Now this Q is the notch sensitivity factor and it is given by increase of actual stress over nominal stress upon the increase of theoretical stress over nominal stress. So this sigma 0 is the nominal stress as obtained by elementary equation. So this is the actual stress kf into sigma 0 and theoretical is kt into sigma 0. So increase of actual stress will be what, kf sigma 0 minus sigma 0, and theoretical stress will be what, kt sigma 0 minus sigma 0. Now we will put this value in this equation. Okay, all this value here. So we get this term, that is k of sigma 0 minus sigma 0 upon kt sigma 0 minus sigma 0. Sigma 0 will get cancelled, it's a common term. So k of minus 1 kt minus 1, this is your notch sensitivity factor. Okay, this factor we are considered in designing. Now I am again showing this equation just to explain some part. So this above equation can be rearranged in this term, that's kt is equal to I plus q into kt minus 1. Now what is this? Suppose when the material has no sensitivity to notch, q will become 0 and kf will be 1. And if when the material is fully sensitivity to notches, q will become 1 and kf will become 2 kt. Just to explain these terms, this rearrangement has been done here. So this is important terms. If q is equal to 0, kf is equal to 1 and q is equal to 1, that's kf is equal to kt. That means material has no sensitivity and material has fully sensitivity. So it is lies between 0 to 1 only. So in general the magnitude of notches sensitivity factor q varies from 0 to 1. As I told you, the notch sensitivity factor for various material for reverse bending or axial stresses and reverse tension stresses are obtained from this figure. Let's see the figure here. This is the chart which help us to find out the value of notch sensitivity. Okay, this is the notch sensitivity factor q. This is the notch radius, how much radius of cracks is there or how much radius of notch is there, and the material. Based on the material you will get the value of q here. Okay, so this is how we can do this thing. So I think you understand this part very easily. So this is the notch sensitivity. Thank you very much.